test.
Welcome to the OscopeWizard!
Well, it's a complete reboot. We just had to do a complete reboot. It is a Tuesday. Of course, we would have to do a complete reboot on the show. Sorry! I think I had some really good jokes too, but I'm glad that somebody spoke up and told me that they can't hear me. Thanks, babe. Thank you so much. Otherwise, I would have been talking to absolutely no one, but very quietly, which would have been a sad waste of oxygen. So, I was going on and on about how I'm going to, A, answer the question, what is an Oscope? Which is it's a burning question on a lot of people's minds, and that is fair because I'm the OscopeWizard, so I should be able to answer that question. And before I did that, I wanted to have a little bit of talk about how getting older kind of stinks. You hope that with age comes wisdom, and perhaps maybe it does, because the younger me would have panicked, cried, ran outside, and just stopped. But older me took the time, stop, assess, solve the problem, start back over, because there's no reason to just abandon something because part of it breaks. With that being said, I can tell that I'm getting older because yesterday was ear hair trimming day, and the mere fact that ear hair trimming day exists lets me know that yes, I am getting older. If ear hair trimming day exists in your world, you're getting older too. And if it should exist in your world and it doesn't, I hope you have a friend who will let you know. Another thing that tells me I'm getting older is I'm not great at social media because I kept asking people to share. Please share. That's the best thing that you can do for me is share this with a nerd in your life. A lot of people share it back with me because I might be the nerd in their life and maybe the only nerd in their life. And that's fair. That is fair. But when I asked you to share, my dear sister, who is younger than me and in fact is good at social media, she let me know that when you do share, you should probably set the sharing to let you share with anybody. I was setting it to share with only my friends, which wasn't terribly helpful. Thankfully, she did step in and let me know that yes, I am an old dad who barely knows how to work a computer. So thank you so much for letting me know and helping me out. Another thing that happened this weekend, I got my second big COVID haircut. We are all getting crazier and crazier haircuts, and I am no exception. Who knows where this will end up? Hopefully, fingers crossed, maybe mohawk mullet. You know, we can all have dreams. I don't know if that'll be allowed at the house, but it would be pretty epic. If you have a crazy haircut, please share it with me. You can hit me up on Instagram at OscopeWizard. It's actually pretty easy to spell. It's spelled exactly how it sounds. OscopeWizard. All one word. Now, what else? At the house, we love chips so much that we actually bought a convenience store worth of chips. 2 convenience store boxes worth of chips. Yes, I did get a haircut. Thanks. We do have, a couple of people on the stream. Thanks so much. So chips, pretty serious about chips. And in fact, when you open up this box, let's see if I can turn it off and turn this back on. You get that many chips, which is a great, oh, now I got 2 things going. I only want one thing going. Trying to get one thing going. A great many chips. These chips. Who knows Utz chips? Utz chips. Story about Utz chips. The first time I had Utz chips was in jury duty. I was in the courthouse with a few moments, many moments, lots and lots of moments on my hand, much like now, and nothing to eat. In the lobby of the courthouse was a vending machine, I think on G7, was buffalo chicken wing flavored Utz potato chips. My first Utz potato chips I ever had. They were life-changing. Now we're buying them by literally the truckload. My son describes them as Lay's, except saltier, which, I mean, to me is a positive. I think that's where I want to go. Some other things that happened over the weekend before, actually, in the last episode, I talked about getting a new cable modem. I was super excited. DOCSIS 3.1 cable modem. It was the cable modem that was recommended by my cable company. And so I got it. So excited to make it happen. Sadly, despite hours and hours of trying to make this thing work, this is where we ended up. We ended up back in the box, heading back. It was sad. It was honestly quite sad. That is the thing about technology. Sometimes you get excited, everything should work, nothing's broken, but for some reason it doesn't work. And it's one of the places where oscilloscopes. So unfortunately, that cable modem was a fail. But we're not going to give up entirely because we do want faster internet here at the techno lair. So we're going to continue to try to get faster internet. Let's talk about what an Oscope is. That's the point of the lesson today. We're a little bit late, so I think starting here, we will probably take about 20 minutes to discuss an Oscope. How's the chat doing? How are we looking in the chat? We're looking good. Thank you. I did get a haircut. I'm glad I do sound. Good is a benefit, a plus. I would take sounding at all at a certain point. So what is an oscilloscope? Let's take a look at what an oscilloscope is. This is an oscilloscope. That's an oscilloscope. Hold on, I've got... Let's see, if I go back to here, this is an oscilloscope. You get an oscilloscope. You get an oscilloscope. I love that episode of Oprah when everybody gets cars. One day, fingers crossed, maybe I can be Oprah level awesome. Probably not today, but one day. So if I go back to my setup, how am I going to explain what an oscilloscope is? And like any good electrical engineering instructor, I have an LED, and that LED is on. And that is how all good electrical engineering lessons begin, with a circuit driving an LED. You gotta begin at the beginning. It's how we all learned electronics. It's how electronics will be taught, I assume, until the end of time, with blinking lights, because we just love blinking lights. So let's back up a little bit and discuss what let me go over here. What questions do we need to answer? So, the question is, what is an Oscope? Well, the really short answer is Oscope stands for oscilloscope. So it's just kind of a cool way of saying oscilloscope. I think it's cool, and that's how you can tell it's not cool, because that's super nerdy. But if I was to read a definition of Oscope, an oscilloscope, previously called an oscillograph, which that's before my time, and informally known as a scope or Oscope, is a type of electronic test instrument that graphically displays varying signal voltages, usually as a two-dimensional plot of one or more signals as a function of time. So that's according to Wikipedia, and if Wikipedia says it, it must be true. But what does all that mean? What is an actual Oscope? If I go back to my setup here, I can see that I'm looking at a multimeter. So let's start with a multimeter. Does anybody know what? We'll continue on. So measuring a voltage, the multimeter is measuring a voltage. The oscilloscope also measures a voltage, but it has a very important difference than the multimeter. It measures a voltage along with time. So why would you care about time when you're measuring voltage? And the reason is communication. So without time, it's very hard to communicate. I can send out a single picture, but without a whole series of pictures presented to you in a timeline like this video, it would not give you the same communication that I have with the video. So just a static picture doesn't tell you the whole story. So time allows me to have communications. And in electronics, we use voltage and time to have communications. So let's do a couple of little experiments. First of all, let's talk about how oscilloscopes are identified. What are some of the identifications used with oscilloscopes? So one of the big ones, one of the ways we identify oscilloscopes is with, let me get it going here, bandwidth. So bandwidth is a real big specification when it comes to oscilloscopes. Almost all oscilloscopes are specified first by the amount of bandwidth that they have. And what does bandwidth have to do with anything at all? I have set up a little experiment. If we go over to my display and I drag this out of the screen and I turn on a little bandwidth filter. So I can do this using sound, which I love sound. I think it's really cool. Let's turn on what is called an equalizer. So this guy, hopefully everybody can see it on the screen, is a filter. I can use this filter to set the bandwidth of the noise coming from my microphone. So if I reduce this bandwidth down to say 10 hertz or 20 hertz, you can't hear anything. Can anybody hear anything? This is a nightmare because before we couldn't hear anything, but now I'm hoping we can't hear anything because I mean it's not to hear anything. So now if I move this up to say 500 hertz, you can probably hear something, but most likely it sounds a little bit like I'm underwater, which is not ideal. Now, as I increase this bandwidth, so if I increase this to say 2000 hertz, so now the bandwidth of this microphone is set to 2000 hertz by this filter. I'm going to begin to sound more and more normal, like a regular talking person, because your ear holes have a bandwidth of about 20,000 hertz or 20 kilohertz. That's what your ears operate at. So if I move this filter all the way up to 20 kilohertz, I most likely sound normal as I can. Oscilloscopes operate the same exact way. They have bandwidths that define how much signal can get, how fast of a signal can they look at. The oscilloscope that I'm using today, to go back over my scope, this guy right here is my RTO 2044. It has a 4 gigahertz bandwidth. And that is the first specification that people ask about when it comes to oscilloscopes. How much bandwidth does it have? This guy has 4 gigahertz of bandwidth. What are some of the other specifications that are important with oscilloscopes? Let's take a look at them. A couple of my favorites are sample rate. That's a really popular one. Memory depth. That is very important when it comes to how long can the oscilloscope look at something. And then, of course, your trigger, because that's going to define when the oscilloscope starts looking. So sample rate, memory depth, and trigger, all very important specifications on an oscilloscope. I actually have a little bit of help from a buddy of mine. He's going to help us look at, let's start with sample rate. Well, That doesn't seem to be working right. I think that might have been Oscilloscope. And I think it might have been trying to tell us something, but I think his sample rate was too low. So what does sample rate do? That's a great question. Let's take a look at it on the oscilloscope. If I open back up my oscilloscope, actually, let's look at the setup. So I am going to change some things about this signal, this blinking LED over here. Let's see if we can get it bright so we can see the blinking LED. Right now the LED is off. You can't see it blink. It's right there. But I am going to turn it back on. So now the LED's on. So off, on. You'll notice that my multimeter, as my LED goes on and off, let's see, we can see the multimeter, both the digital multimeter on the bottom, the analog multimeter on the top. Yes, when your sample rate's too low, you need more samples. That is very true. So let's figure out how we can get more samples. So if I turn it on and turn it off, I can see the voltage going up and down. I can make this LED blink. So instead of just being locked on, let's change this to a blinking LED. So now it's blinking. So it's going up and down. So on and off, on and off, on and off. So I could attempt to sample these things myself and make my own oscilloscope so I can see that I could write down the voltage. It looks like it goes from 0 volts to 4 volts. I can see up here on the, using my analog multimeter because it's not ranging. Let's turn off auto range over here so it doesn't range. Now I can see that it bounces between 3.3 volts and 0 volts. I would have to manually write that down without an oscilloscope. If I go over to the oscilloscope, on the other hand, I can actually see what that signal looks like. So if I zoom out on this oscilloscope and give myself a little bit more time, so let's say I want to make this 1 second for division, and I have 10 seconds of time. So now I can see this signal is bouncing up and down on the screen, and the oscilloscope is drawing it. That's what the oscilloscope does. It draws the waveform on the screen with a voltage axis on the y-axis and a time axis on the x-axis. So I have voltage up and down, time left and right. That's the fundamental basis of what an oscilloscope does. So sample rate. I can see that this guy right here is about 1 second. Actually, each pulse is about half a second because each division is 1 second. So 0, 1, 2, I can see that there's half of the pulse is high and then half of the pulse is low in this 1 second division. If I change my sample rate to something below a second, let's see, what is my minimum sample rate that I can enter here? I think I need a little bit more time. Let's say 100 seconds of time. And now let's make this minimum. So this is going to be 4 samples per, let's make it 5 samples per second. Nice even sample per second. So now I'm going to hit run. And now it's going to slowly sample and I'll start seeing this guy move across the screen. Now, if I change my signal to be a little bit faster, so instead of happening every second, let's make 10 things happen every second. So that would be 10 hertz. Let's see what my sampling looks like. Uh-oh. My signal went away. It looks like it's not going up and down anymore, which is kind of sad because I know that I set the signal up to go 10 hertz, and yet my oscilloscope is not measuring it correctly. And that is because our sample rate's not high enough. which is the same reason why we couldn't see Serious Gabe before. So if I went back and looked at this video, I don't have enough samples per second. I can see he's trying to talk to us, but I can't tell what he's trying to say. So, sample rate. The next thing that I wanted to talk about was, what was the next thing? Memory depth. Memory depth is the next thing. So let's see what memory depth is all about. Looks like I can see the beginning of the message, but I'm not getting the entire message. So memory depth is all about how long can the scope look at something. If I go back over to my oscilloscope, let's take a look at the oscilloscope again. I can find it somewhere buried in here. The oscilloscope, here we are, the oscilloscope's back. I can, first of all, I can see that I am running at 5 samples per second. Let's crank that up because I have it running at 10 hertz. So let's grab a little bit less time. Let's say 1 second per division. So we'll grab 10 seconds. And now we are, let's see, let's sample at a kilosample. So now I can see a whole bunch of stuff happening. In fact, I'm zoomed out so far, it's very hard to tell exactly what is going on. So let's zoom in a little bit more. Let's grab 1 second of time. Now, I can see my 10 pulses happening, which is really cool. And I'm grabbing a full 10 seconds of time, which is nice. So I have a nice deep memory capture to see exactly what's happening. I can see the pulses on the screen. If I was to go back to my setup here, I can also see my light blinking. Can everybody see the light blinking? So it's blinking at 10 hertz, which you can still see with the naked eye, which is kind of cool, I think. You'll notice that my multimeter at this point, even at 10 hertz, is really struggling. It can't tell that there is any sort of pulse. It looks just like a single voltage to the multimeter, which is the very reason why you would need a scope. The question in chat, why is my channel purple? That is a very fair question, and that is because it's actually pink. Just because I like the color pink. It's probably coming up as purple, but it's actually pink, so it's supposed to be pink. Personal preference. It takes all kinds. Let's go back to the scope. I can see my signal. I'm grabbing the full signal. I'm sampling it fast enough. But I noticed that it's kind of bouncing around, like the edge is here, and then the edge is over here, and then I have an edge right in the middle. I want to consistently have a rising edge right in the middle of the screen. And that is where our last major piece of the oscilloscope comes into play, and that is the trigger. So the trigger defines where the oscilloscope starts looking. So where do you want to begin? It is a fundamental part of oscilloscope operation. I have a really good example. So if I was to go back to the Oscope with a Serious Gabe, you can see he's trying to tell me something. Let's see, what side is it? This side. You can see he's trying to tell me a story, but I'm not at the beginning. I also don't have enough memory to get the story right now. But I can fix all that. So if we were to go back to this oscilloscope, how does the trigger work? Very simply, I have a trigger position or a trigger indicator right here on the oscilloscope. Just grabbed the wrong window there. Trigger position right here on the oscilloscope, and I can drag this trigger up. And now this trigger is saying triggered on the rising edge, so you can see a little arrow right there, of channel 1. and I am triggering on the rising edge of channel 1. So now I could zoom in on this signal really easily. So if I instead of doing let's zoom in a little bit. So now we can see this edge. I can see a nice edge. Now my trigger is set up perfectly, and I'm beginning exactly where I want to. So I've set up my sample rate, I've set up my memory depth, and I've set up my trigger. So now the oscilloscope is looking at the right signal. I go back to my buddy who was trying to help me out. He had problems as well. So he had sample rate problems. So let's see if we can fix that. If I go over here. Okay, get the sample rate squared away. Now I want to change the trigger because I'm not beginning at app rate. So let's get that figured out. All right, and now I have a memory depth problem. So I can see, I'm trying to get it, but I don't have the memory depth set up right. Let's see if I can get everything set up right and hear what this guy is trying to tell me.
Operates! I am Serious Gabe, the Serious Oscope Wizard, and I have a very important message for you today. Hickory dickory dock. The mouse went up the clock. The clock struck 1, and the mouse went down. Hickory dickory dock. Disparate!
Well, there are positives and negatives here. I've managed to conjure a baby carriage, but I seem to have turned myself into a tiny, stuffed kitty cat.
I'm gonna be honest. That was a lot of work to get something straight. To hear that. Happens a lot in engineering. You work towards the problem, and then when you find the solution, you're like, why did I even bother? All right, so hopefully we all know what an oscope is now. An oscope's an oscilloscope. It measures voltage on a time axis and draws a picture of it for me to make it easy for me to understand exactly what's happening in my circuit. If there's any questions, I'll be hanging around in the chat. Hopefully you enjoyed it. Sorry for the mic, sorry for the restart, but you know, live is hard and life can be a little bit hard. I'll see you guys next time. Bye.